techdaily.ai, your source for technical information. This podcast is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.
Welcome to the deep dive. Today we're getting into something that's, well, absolutely foundational for this whole AI explosion we're seeing everywhere.
Right, something that often sits kind of quietly in the background.
Exactly, behind the scenes, but it can totally make or break your entire AI strategy.
We are talking about data storage. And while, the headlines are always screaming about the powerful new GPUs and these incredibly complex AI models.
The sexy stuff.
The sexy stuff, right. But the truth is none of that really works without just, massive amounts of data. And not just having the data somewhere.
It needs to be usable data.
Right. Instantly accessible, in the format you need, at the speed you need. That's really the crux of it. It makes sense. I mean, think about all these AI and machine learning projects transforming industries. You've got autonomous vehicles processing sensor data, financial models looking at market history, medical imaging.
All of them. They rely on data sets that aren't just large, they're colossal. We're talking terabytes, petabytes, even exabytes now.
So our mission today for this deep dive is to really unpack why traditional storage systems, frankly, just weren't built for this kind of scale and speed.
Yeah, what is it that AI specifically demands from storage?
And why getting your storage strategy right is, every bit as crucial as picking the right compute hardware, maybe even more so sometimes. This is a deep dive really crafted for you, the curious learner, trying to navigate this data-hungry world of AI.
Okay, so let's dive straight into that core issue then, the bottleneck. Why does AI need something so fundamentally different from just, regular old storage?
Well, if you picture those incredibly powerful AI processors, that GPUs, TPUs, all those specialized chips, they're like data processing factories, right? They can chew through billions, sometimes trillions of operations every second.
Insane speeds.
Exactly. Now imagine trying to keep that factory running flat out, but the raw materials, the data, are just trickling in, like one truckload at a time, stuck in traffic jams miles away.
That's a perfect analogy. Because traditional storage systems, they were designed for a different era, often optimized for accessing, say, structured data in a pretty sequential way.
Like reading a file start to finish or database lookups.
Precisely. But AI, and especially deep learning, needs to grab vast amounts of unstructured data images, video, audio, text in a massively parallel way.
So not one truckload, but thousands arriving at once.
Yeah, thousands of truckloads, maybe with different materials, all needed simultaneously at different points in the factory, constantly. Training a big neural network, for example, involves reading data from just countless files or objects concurrently, often in really random access patterns.
And this mismatch, it's costly, isn't it? I mean, those compute chips, the GPUs, they're seriously expensive.
Extremely.
So if they spend most of their time just sitting there waiting for data from a slow storage system, you're burning money.
You're absolutely burning money. You're paying for idle processing power. The goal is always maximum GPU utilization.
Yeah.
That directly impacts how fast you can train your models.
And how productive your data scientists are, I guess.
Critically important, yes. Slow storage means slow iteration times. And in the AI race, speed is everything.
So this creates that performance gap people talk about.
A huge one. Compute power keeps, rocketing up. But if your storage layer is stuck in the past, that becomes the main limiting factor, the bottleneck for your entire AI pipeline.
So upgrading storage isn't just about adding space.
Not at all. Moving from a legacy system to one actually built for AI can take a training job that might have dragged on for weeks.
Weeks.
Yeah, and shorten it to days, maybe even hours in some cases. It's a massive difference.
Okay, so it's clear we need something different. It's not just a big hard drive anymore. The storage needs to be smart, fast, able to feed these hungry machines.
Exactly. And then to make things slightly more complicated, there's this sheer diversity of data types involved in AI projects.
Right, yeah. Not all data is the same, and I guess not all AI uses the same kind of data.
Precisely. You've got all that unstructured stuff we mentioned, images, videos, sensor streams, audio files. That's really the bread and butter for deep learning.
Okay.
But then you also have structured data. The classic rows and columns in databases. That's often used for more traditional machine learning or financial analysis, things like that. And increasingly, you see semi-structured data, too, like JSON or XML files.
And I'm guessing different storage types are better suited for these different kinds of data and how they're accessed.
They definitely are. For that structured data, especially where you need high transaction rates, like in databases, block storage is often the go-to. It gives you direct low latency access to fixed size blocks. Good for transactional stuff.
Okay, block for databases. Makes sense.
Then, for those massive unstructured data sets that lots of compute nodes need to access all at once, like in a training cluster, that's where parallel file systems really shine.
Like Luster
Yeah.
or BGFS, things like that.
Exactly. Those kinds of systems. GFS is another one. They're specifically designed for super high throughput and handling concurrent access to really large files across many, many servers.
Okay, so block, parallel file, and then there's object storage. I keep hearing object storage is crucial for AI, but like you said earlier, my brain still kind of defaults to thinking of it for backups, long-term archives.
And you're right. That was its traditional role. But object storage has, well, it's evolved dramatically. It's become so important because, first, it offers virtually unlimited scalability.
Like exabytes.
Potentially, yeah, exabyte scale. And usually at a much lower cost per terabyte compared to file or block, especially for data that isn't needed instantly, maybe cold or warm data. So it's ideal for building these huge data lakes, storing just colossal amounts of unstructured data.
But the key change is performance, you're saying. How did object storage get fast enough for active AI work?
Right, performance. That's the big leap. It's partly down to leveraging modern hardware, especially flash storage. Putting flash into object stores drastically cuts down the latency.
Okay.
And crucially, adopting the S3 API. That's become the de facto standard, right? So modern object storage is now easily usable by a huge range of AI and ML platforms and tools.
So it plugs right in.
It plugs right in.
Right.
Yeah. Will it always match the absolute lowest latency of dedicated block or file for every single task? Maybe not. But high-performance object storage, often built on flash, can absolutely serve as a really performant foundation for many AI data lake use cases today.
So it's graduated from being just a cold archive to being like a living repository for AI data.
Exactly. Modern object storage is now actively used for things like feature stores, these central places, to keep data features used across lots of models. It's used for vector databases, too. Those are critical for similarity search on unstructured data, storing vector embeddings. Systems like Milvus, for example, can use object storage as a backend. And it's used for model stores, managing the actual trained AI models, with versioning and access control.
So active parts of the AI lifecycle, not just backups.
Absolutely. These are core components.
Yeah.
And some advanced storage platforms, like the kind StoneFly offers, are actually designed to handle this whole mix. They can provide block storage for databases, file storage for sharing, and high-performance object storage for those AI data lakes, all managed from a single system that can start reasonably small and scale out as needed.
That makes a lot more sense. It's about having a flexible foundation that can handle all these different data types and access patterns, often using a mix of these storage approaches.
Precisely. Which brings us nicely to the specific technologies and characteristics that really make storage AI ready.
Yeah, this is where the architecture itself really shifts, isn't it? It's not just about how much you can store anymore.
Absolutely not. The number one characteristic is a massively parallel architecture. The storage system has to be able to handle thousands, maybe even millions, of simultaneous requests for data coming from that big compute cluster.
So, high concurrency.
Super high concurrency, incredibly high throughput. We're talking moving gigabytes, even terabytes of data per second, and very low latency. Those are paramount. It also needs to scale well. Performance and capacity should scale linearly as your AI demands grow.
Okay.
And really importantly, it needs to be optimized for handling unstructured data access, especially things like random reads, which is a super common pattern during model training phases.
So what technologies are actually enabling this? I hear NVMe mentioned constantly.
Yeah, NVMe is a total game changer for AI storage. It's a communication protocol and interface designed specifically for flash storage like SSDs.
Right, not for spinning disks.
Exactly. It offers much, much higher bandwidth and way lower latency compared to the older interfaces like SAS or SATA, which were really built for slower hard drives. NVMe is inherently parallel itself. It can handle thousands of commands being queued up and processed at the same time.
Which sounds perfect for AI's parallel needs.
It's critical, especially for feeding those demanding AI processors during data loading during the actual training iterations, and also when writing checkpoints, saving the model's progress. You need to move huge amounts of data incredibly quickly and handle tons of requests concurrently in those moments.
And NVMe works hand in hand with flash storage, the SSDs themselves, right? Compared to traditional spinning disks.
That's the foundation NVMe sits on for that high performance.
Sure.
Flash storage, SSDs, just provide a massive leap over hard disk drives, HDDs. They dramatically reduce latency, the delay in getting the data, and they massively increase IOPS.
IOPS, input-output operations per second.
Right. Think of IOPS as the number of small individual data requests the storage can handle every second. AI workloads, especially if they involve tons of small files or those random access patterns we mentioned, often need extremely high IOPS. SSDs deliver that.
Especially for hot data.
Exactly. Data that's accessed really frequently. Or for things like caching metadata, which can speed up access even to larger data sets stored maybe on slower tiers. Now, SSDs are generally more expensive per gigabyte than HDDs.
Yeah, that's the trade-off.
It is. But newer flash technologies, like QLC quad-level cell flash, are getting denser and bringing costs down. So we're seeing more cost-effective all-flash systems, or clever hybrid solutions that mix flash for performance with disks for capacity.
So NVMe and Flash are really driving this parallel high-speed access AI needs. And as we discussed, object storage is adopting these too, becoming a performant layer for those massive data lakes.
Exactly. Performance-optimized object storage that uses Flash and NVMe can handle that exabyte scale data, but still provide the speed needed for a lot of AI training, especially if you combine it with smart caching strategies. And again, that S3 API support is basically non-negotiable now. It's the common language for cloud-native and modern AI tools.
Okay, so we have the building blocks. Parallel designs, NVMe, Flash, faster object storage. Let's maybe zoom out a bit now to the bigger strategic picture. All this massive data accumulation leads to this concept people call data gravity.
Yes, data gravity. The idea that data, like a planet, has mass and attracts other things to it, more data, applications, services.
Precisely. And the bigger a data set gets and the more applications you build around it, the harder and, crucially, the more expensive it becomes to move that data somewhere else.
And AI is like pouring fuel on that fire, isn't it? It doesn't just use data, it generates tons more data. During training, maybe through synthetic data generation, and of course from the output of the models doing inference.
Which really exacerbates that data gravity problem.
Absolutely.
And this creates some serious strategic headaches for IT departments, I imagine. You have to make these really critical decisions about where your data is going to live and where your AI compute power should be.
And they're not always the same place, or shouldn't be. Data location matters differently for, say, training, which needs that super high throughput access to huge data sets,
Right.
versus inference, which might be happening at the edge and needs very low latency for real-time responses, but maybe accesses less data overall.
And the costs associated with data gravity, moving data around.
Oh, they can be enormous.
Yeah.
Moving petabytes of data, especially out of a public cloud, those egress fees can be absolutely eye-watering.
Ouch.
Yeah. Plus, you got regulations, compliance rules, GDPR, IP, whatever it might be, often strictly dictating where certain types of data must physically reside. That limits your options for moving it around, too.
So how do organizations even begin to tackle this? It sounds like you need a real strategy for managing that gravitational pull.
You absolutely do. It starts with really understanding your key data nodes, where your biggest, most active, most valuable data sets are located.
Okay.
Then, strategies often involve minimizing unnecessary data movement. For example, can you do some processing at the edge, where the data is generated, instead of hauling everything back to a central data center just for initial cleaning or filtering?
Makes sense. Process closer to the source.
Exactly. And leveraging storage solutions that are specifically designed for hybrid and multi-cloud environments becomes really crucial. Solutions that can give you a unified view, or maybe a consistent data layer that spans different locations, your on-prem data center, maybe multiple clouds.
So you can manage the data flow without these huge, costly migrations all the time.
That's the goal. Centralized storage platforms, again like those from StoneFly, often aim to provide exactly that. A consistent, scalable foundation that can serve workloads, whether they're running on-prem, in the cloud, or across a hybrid setup. Makes managing that data gravity a bit easier.
It really sounds like you need to think very carefully about your data architecture before you even start building the AI models themselves.
Absolutely. Get the foundation right. And, the reality on the ground can throw up some very practical challenges, even for individuals just trying to learn this stuff.
Right. We saw some discussion around even just fundamental access issues. Like someone mentioned being in a region where getting international payment methods set up for cloud services is really difficult.
Exactly.
Yeah.
And they're trying to figure out, okay, how do I store data just to learn AI? They might look at the free tiers on cloud platforms like GCP or AWS, which are great to start with for small data sets.
But you have to watch them like a hawk.
You really do. Monitor usage constantly to avoid getting surprise bills. Or, as an alternative, maybe they consider using local NVMe SSDs right on their own computer. That can actually be surprisingly performant for smaller training runs, especially if you only need, say, a few gigabytes for practice data sets. It avoids relying solely on cloud storage right away.
It just highlights that this storage challenge exists at every single scale, from somebody learning Python to a massive enterprise.
It really does. And on the enterprise side, managing some of the really powerful distributed storage options, like Ceph, for example, while it's incredibly capable, it does require significant expertise. It can be pretty complex to configure, tune, and maintain properly at scale.
Yeah, not for the faint of heart.
Definitely adds complexity. And look, regardless of the solution you end up choosing, testing and validation are just non-negotiable. You have to test how your chosen storage actually performs with your specific AI applications, your ML frameworks, whether it's TensorFlow or PyTorch, and things like your analytics platforms like Spark.
Spec sheets don't tell the whole story.
Not even close. Those performance numbers mean very little if they don't translate into faster model training or quicker data processing for your actual workload. Companies invest a lot of time and effort validating storage solutions under realistic AI conditions.
And it's always going to be a bit of a balancing act, right? Between the absolute top-tier performance, maybe an all-flash NVMe object store, and the cost-effectiveness of maybe hybrid systems or even disk-based systems for data that's not accessed as often, or for different stages in the AI pipeline.
It's a constant optimization puzzle. You really need to understand your data's access patterns, its life cycle, how often is it read, written, updated, and the specific performance demands of each stage of your AI workflow. That's the key to finding the right balance between speed and cost.
So wrapping this all up then, it's just incredibly clear that data storage is, well, it's far more than just a place to dump files. It really is, without any exaggeration, a fundamental pillar that dictates the performance, the scalability, and ultimately the success of these AI and ML workloads.
Yeah, traditional systems, they were built for different times, different needs. They just can't keep up. Modern AI demands purpose-built storage solutions. They need to be massively parallel, scalable, high-performance systems capable of handling all sorts of diverse data types with high concurrency, massive throughput, and really low latency.
And optimizing this data layer, it's not just a nice-to-have feature, it's absolutely essential. It's how you make sure you're not wasting all that money you spent on expensive compute resources.
Right.
And it's how you genuinely accelerate your AI initiatives, solutions designed specifically for these demanding requirements, providing that scalable, high-performance storage, maybe including things like hyperconverged infrastructure or specialized AI servers. They're becoming just critical parts of the modern AI stack.
And thinking about how fast AI itself is evolving, it really makes you wonder, what's coming next for the infrastructure that actually underpins it all?
It certainly does. And maybe here's a final thought for you, our listener, to consider as you reflect on all this. As AI becomes even more sophisticated, more embedded in everything we do, and as it generates ever more complex data itself, how will AI itself start to influence and actively reshape the fundamental architecture and the optimization of the very storage systems that it relies on?
AI optimizing its own storage. Interesting thought.
Something to ponder. techdaily.ai, your source for technical information. This podcast is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged, and VMware, Hyper-V, Proxmox Cluster, AI servers, SA365, a turnkey security appliance in public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.